Okay, hello friends. We are bigdatahands.com. Today is the day 17. So today we'll see polynomial regression. So before that, I will show you our website bigdatahands.com. This is our website, and, and here you can see our contact numbers and the email ID supported bigdatahands.com. If you have any doubts, you can message us in this number. Our YouTube videos will upload on the YouTube. Uh, the recordings will upload in YouTube. Our channel is bigdatahandson.com. So the previous sessions and the 16 sessions will be uploaded in our YouTube channel. Yeah, this is our YouTube channel. Oh, sorry. This one. So bigdatahandson.com. So you can see here the videos are uploaded. So you can watch these
The
videos.
past 2 days video was not uploaded, and we are able to
Yeah.
upload it. So you will get it maybe in 2-3 hours. No, you will be getting all three videos.
So until
Sorry
part
to
14
interrupt.
is uploaded, right? Okay, okay. Until part 14 is uploaded.
Yes, Irfan. Yeah.
Yeah, okay, okay. So let's continue to our today's session. So as I said, today we'll see polynomial regression. So yesterday we have seen a simple algorithm, that is a linear regression. So what we do that in using the linear regression, we just draw a straight line. So the straight line is nothing but our prediction line. Okay. So let's say we have a data like this curve. Okay, we have a curved data. So if you fit the regression line, so you will see some points are more far away from the line, right? So if you have a curved data, so that time the line should go on as
Irfan,
a
little
curve.
bit louder, Irfan.
Okay, so the line also needs to be a curved line. Okay, so for that time we use a polynomial regression. So polynomial regression used a curved line, right? So polynomial regression is a form of linear regression in which the relation between the independent variable x and the dependent variable y is modeled as an nth degree. So as you're seeing in the curve, right, there is a degree. Okay, so if you change the degree, it will fit okay. So polynomial regression fits a nonlinear relationship between the value of x and corresponding conditional mean of y. So denoted as E, error. That is an error actually. So that means, let's see here. We have a straight line, okay? So there is an error between this point and this line. So the error, if you manage to solve, then you will get a perfect line, the curved line, right? So we add the error also. If you add the error, then the line will come here in the point. Okay, so that's what we do in the polynomial regression. Usually we use y equal to mx plus c for a straight line. For a curved line, we use we have already studied in our higher secondary schools, like we know that, right? uh, like mx plus c plus x squared, mx squared. Okay, you can see that b0 is c. Okay, so don't confuse it. B0 is a c. Okay, b1 and b2 are the slope m. Okay, so we are taking into the degree of 2. You can see here x squared, right? So now the degree of this line is 2. Okay, that's what the polynomial regression is. So you can see here some examples. The line fitted in the points, you can see a linear line is this one. So if you draw a polynomial line, this will be like this polynomial regression line. Okay, so before the polynomial regression, you need to know about two things. One is overfitting and underfitting. This often comes in the polynomial regression because we are fitting to the data the- as the data is like. Okay, so the data is curved, then our line also will be curved. So okay, that time two things will happen: overfitting or underfitting. So overfitting happens when our line regression line fitted very too correctly, then the overfitting will happen. So overfitting refers to a model that models the training data too well. So that means you can see here the points on the line are very correctly matched, right? So that time the overfitting will happen. So that means, let's say I'm buying a shirt, the shirt will fit for me correctly. If you give some other person, that will not fit. He cannot use the shirt, right? So that's the thing here in the overfitting. What happens usually if you build a model with overfitting? It gives a good accuracy on training data. Okay, if you give another data, that is a testing data, it will not predict that much accuracy what in the training data it's giving. Let's say in training data it's giving 99%. If you give some other data like testing data, it will give only 70%. That cause of overfitting. Okay, so overfitting happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. Okay, so overfitting means the regression line is fitted for the training data only. If you give a testing data, it will not predict correctly. So like that, this is an opposite of overfitting, that is underfitting. The line is not fitted correctly on the training data, that is underfitting actually. Underfitting occurs when a statistical model or machine learning algorithm cannot capture the underlying trend of the data. Intuitively, underfitting occurs when the model or the algorithm does not fit the data well enough. So that time the underfitting will happens. So we need to handle the both overfitting and underfitting. Uh, so we need to have a line, optimal line. Okay, this is an optimal line. uh, so this is the overfitting. Sorry, this is an underfitting. Okay, this is an overfitted line. So this is an optimal line, you can see. Okay, so in the polynomial regression, the degree affects the line actually. If you change the line, you can see here the degrees are so the red dot lines, the red line is degree 1. You can see that is an underfitting here in the degree 1. If you change the degree to 2, there's a line in the line here in here. We can see that. So the pink line is degree 3. Okay, that's what the degree affects the line actually. If you change the degree one more, then it will be a overfitted line actually. Okay, okay, we'll see the implementation. Okay, this was the yesterday the uh, we are created in the scratch, right? So instead of the two lines we have written there, I just uh, pasted a different line like this: for I in x and x mean difference dot append I minus x mean. So just we did simply on the single line, but that doesn't work. Then I did like this. Now it working actually. Yesterday we have this faced this problem, right? Okay, let me show you last. Okay, first what I will do, I will just copy these two things, two lines. Okay, I will create a new file. We'll paste it here. So it's simply a polynomial data actually, x and y. It will give you a polynomial data. So using this data, I'm going to demonstrate the polynomial regression. Okay. So first, let me import the pandas and numpy, and import the numpy library, and import the matplotlib library to visualize the data. Okay. So now let's save this file. Poly. Let's save as poly. Oh, we are not put it dot py. Dot py. We forgot. Okay. Now let's run this code. Okay. Now you can see the x and y here. We have 20 observations. So let's visualize this, and you will get the idea. It's not responding. Okay. So now we'll create a plot. Plt dot plot. Here we'll give x and y, and then plt dot show. So here you can see the plot in the plots tab. Okay, that's not actually. Just okay. We want to scatter it, right? Sorry, not plot. We'll do scatter. Okay, you can see here. Now this is a curved data, right? So in this curved data, we are going to fit the polynomial regression line. So polynomial regression is not an algorithm, we can say. It's simply a pre-processing step like. So we use the linear regression only, but we'll apply the polynomial regression. So then what we need to do now is we have the data. Now we need to uh, import the polynomial features first from sklearn dot polynomial, sorry, no, pre-processing, import polynomial features. Here you can see polynomial features. So you can see there's a pre-processing step. It's not a algorithm. It's just a pre-processing step which will uh, take it to the degree of 2, degree of 3. Okay, our data will convert to the degrees. Okay, that's what we are going to do. So now what we need to do is we need to create an object. Let's say poly equal to polynomial features. Here you need to give degree. Degree equal to, let's start with 2. Okay, and now, and then we have the object. We need to fit that object into the our data. Okay, poly dot fit underscore transform and the x data. Okay, and x will be transformed to the degrees. Now, so we have a new data that is x here. Let's with the capital X. Okay, now let's apply the polynomial features. Okay, it's just a problem of reshaping. So we need to reshape to -1 comma 1. That's it. So now in the variable explorer you can see the capital X here. This you can see, if you have a degree of 2, then it will create like this 3 uh, columns it will create. Okay, now what we need to do is using this data, a new data here, using the polynomial features, we need to use this data for the linear regression. So for that we need to build a linear model. We need to import the class for the linear regression. Linear model import linear regression. So of course is the class. You need to create an object and then you need to fit into the data lr dot fit. So here you need to give x the polynomial features only. So we have capital X here, comma the y data. Okay, now let's run this 3 lines. So now we have fitted to the data. Now we need to predict it. So simply ypred equal to lr linear regression dot predict of x. The same data will give. Okay, and then we have the ypred. Using this ypred we'll visualize. Okay, so let's run this ypred. Okay, now we have the data. Now what we need to plot the data, right? Plot uh, x comma ypred. Now y is an actual data, this is the predicted line. Okay, So the line will not be accurate. What we need to do is we need to sort that actually. If you sort the datas of y pred, you will get a perfect line actually. So we need to sort it. Sorted here we will give x and y both, x and y pred, y underscore pred. And here we need to give another parameter, that is key. We'll sort based on the x only, right? Where's the y? Okay. So key here will be we need to import another library, operator. So here when you can give operator dot item getter of 0. So that means you need to sort based on the x. Okay. After this you will get the x and y. So we need to zip it and give all the datas in the sorted. Okay, that's it. So now we'll run. So now you can see the line here, right? So because of the outliers, the line is affecting. So polynomial regression also will affect by the outliers. Okay, we'll run another time. Actually there's a randomness here. So np dot random we are doing, right? That's why every time the different data is coming. Okay, so we'll try to change the degree. If you change the degree to 3, let's see what happens. So you can see now you just trying to fit to all the datas. The line is trying to fit. So now we know that polynomial features, if you we want to apply, there's a pre-processing step. If you have a curved type of data, then you can apply the polynomial features, and then you can create the linear regression model, and then you can just fit into the datas. Okay, so let's see some other examples using the data sets. Now we are just created a dummy data using the random normal. So now we'll try to use different data. Okay, so this will work, the polynomial features will work only if you have a curved type of data. Okay, so I don't think I have that. Let's see. Okay, let's read the file. Read underscore csv. Here of course we'll give the path, right? Data set. Okay, now what I'm going to do is to know if it has a polynomial type of curve type of data or not. So I will plot the data using a Seaborn library. So what I'm going to do is sns dot pair plot of the data. Okay, I will comment all these lines. Okay, it will take more time for creating the plot actually. That will be a very big plot, pair plot. So it will create for each and every columns. It will show the relationship. So that's what the use of pair plot actually. Okay, you can see here now. This is the pair plot. So now you cannot visualize that. So what we can do is let's try to save the file. So now you can see here. So this plot is the relation for every data, every columns. It will show the relationship. So here more than like we don't have any, I think. So we don't have any polynomial curve data here. It's just simply randomness data. So we have some of the variables are polynomial. So let's try to fit if it is giving a good accuracy or not. Oh, okay. Okay, now so for this data we need to uh, know the independent variable and dependent variable. For here uh, price of unit will be the independent dependent variable, and all other columns are independent variable. For number it's a unique one, so we'll ignore that. We'll take from the transaction date to longitude as a x variable. Okay, so for that we need to split the datas x and y. What we can do is data dot ilog using the index location. So we want all the rows, so we can put column there, and after that we want to select the columns. So first it's all the rows, and then the columns will be from 1 to, sorry, because the first column is 0 index, we don't want that column. So the index will start from 1 to uh, sorry 1 to -1 actually. So upper bound is excluded in Python, we know that. So we are excluding the last column. -1 means last column. We are excluding the last column. So and then we'll get from transaction date to longitude. And then the y will be data data dot ilog is last column, so we can say simply -1. Okay, and then after this operation, what we want to do is we want to split the dataset into training and testing. For demonstration purpose, in this step I don't split the data. So for this type of data we are reading here, we will split the data set into test and train. So here we got the data, transaction date to longitude, and the y data is price of unit. Okay, now this is a data frame, so we'll convert it to a numpy array using dot values. Okay, the same for y. Okay, so now we'll split the data set into training and testing. We need to import the train test split from the sklearn library dot model selection import train test split here, right? And now it will give four values: x train, y train, and y test. We'll call the function and give the data x and y, and we will give a parameter, that is test size. We give the size of the test data as 0. Let's say 0.25. What happens? Okay, sometimes this happens. Will hang my system. Okay, it put 25 and random state as as 0 will start. And now after this, what we'll do, first we'll run these two lines. Okay, now we got the test and training data, and then now we need to apply the polynomial features for the training data. So x train, x underscore train will apply x underscore train. So now we have multiple features in the training data, so we don't want to reshape it. And for the testing data, we'll just transform it as like standard scalar we do. Okay, so now we'll apply the polynomial features. something which is capital X. Instant is not fitted yet. Call fit. Okay. Okay, now we got the X test and X train, the polynomial features applied. So now we'll create a linear regression model and we'll give the training data, the polynomial data. And then we'll predict the testing data. Okay, now we got the predicted data here, and the actual value is testing data. So here both are this one. So that's the difference. We'll calculate the error using the R2 score or the mean squared error. Okay, so let's import that from scaleon dot metrics. Inside the metrics only we will find the uh, R2 score and the mean squared error, comma mean squared error. Okay, so we'll calculate MSC mean squared error with given y test and y train. Y pred. Okay, and for R2 score, the same value we need to give y test, y pred, actual and predicted. And now then we'll print the R2 score and MSC. R2 score. Okay, let's run this. So now the auto score is 0.37, is very low. So we'll try to improve or decrease the degree. Okay, that if you change the degree to, it's giving 0.67. Or we can improve the test size and random state. Let's try that. 0.3. Okay, 65. Change the random state. 4. Okay, now it is increased 0.69. So like this we can tune the parameters and we can improve the performance also. Not good. I think the 4 is good. I think that's given me 0.69. Or we try to change the degree to 4. No, it's giving -1. Degree to 1. uh, the correct is degree to 2 only. Okay, we keep it as degree 2, test size 3, 30%, and random state as 4. So now it's giving me 0.69% accuracy. Okay, I think that's it for polynomial regression. You have any doubts? It's just a pre-processing step you need to apply for the polynomial regression. Here you need to import the polynomial features. You can create a object with given the degree you want to apply to the training data and testing data, and then you can create the model as usual. Will create, right? The same will create. If you have a curved type of data, it will improve the performance. Okay, as in this data I don't I think we don't have any curved data, so that's why. Let's try without this one. Okay, without polynomial features, it's giving me 0.57. If I fit the polynomial features, then it's slightly improving the performance actually from 57 to 69. So you can see there is a improvement, right? So we'll end up this session. Any doubts you have? Any doubts?
No.
Okay. So we are bigdatahandson.com. Our website bigdatahandson.com. You can visit our website. So this is a part 17 actually. So we are uploaded the recordings in our YouTube channel bigdatahandson.com. Until part 14 is uploaded, we'll upload the two videos, that part 15, part 16, and today's videos also, part 17, as soon as possible. So this is our contact number. If you have any doubts, you can message us in number 978988844, and you can send email through this email ID support@bigdatahandson.com. Okay, let's meet tomorrow.
Uh,
Bye.
Hi, there's one doubt.
Okay, what is the doubt?
My friend was suggesting stats model dot formula dot API, some library. He said that will be more convenient.
Stat
Can you?
models.
Uh, it's an
No,
API.
I think. Yeah, stat
Stats model.
models
Uh,
will use uh, for statistical analysis. I think if you have a, like for example, hypothesis testing, use the t test, right? Z test
oh, okay.
can use for that. Actually that statistical analysis we'll do with the stats model, but creating machine learning models we'll use scikit-learn. Okay.
Okay. Okay.
Okay, have any doubts, any other doubts? Okay, so let's meet tomorrow. Mm, okay, someone messages, could you please show the link for today's data source? Yeah, you can get it from Kaggle website. Sorry, Kaggle. Yeah, so I can go to the data tab here and type the real estate. Real estate. Mm, here I think. So this is the data set actually, which I'm using here. Real estate. You can see this one. Just loading actually. Okay, this is the data. You can get it from the Kaggle website. Okay.